So good morning all. This is an consecutive seventh lecture of our fluid mechanics regarding the basics preparations for the gate classes or the gate of the civil engineering rather. In the previous lecture, we have continued for the channel hydraulics and we have covered most of the part. Now today we are going to cover about the hydraulic jump, that is the rapidly varied flow, and some of the parts related to the GVF. In the previous lecture we had seen the gradually varied flow, then it's a dynamic equation, then application of the dynamic equation in the classification of the channel slopes, and further we had seen that how it is applicable for the classification of the flow profiles. So we'll have a quick review of that and we will proceed further. So classification of the channel bottoms, in that we had seen that classification is based on the dynamic equation of the GVF, that is a variation of the depth of the flow along the channel bottom, that is dy by dx is equals to SO minus SF divided by 1 minus FR square, where SO is the channel bed slope and SF is the energy line slope rather, and FR indicates the Proud number at the Proud number. So as per that, the channel slopes were, first one is the critical channel slope, where normal depth is equals to critical depth and the critical flow occurs at the normal depth. Then mild channel slope, where the bed slope is less than critical one and the normal flow depth is greater than critical one, where the subcritical flow occurs at the normal flow depth. Then for the steep channel slope, bed slope is greater than critical channel slope rather. For the reference, we are treating it as a critical one, and the normal flow depth is less than the critical flow depth, where the supercritical flow occurs at the normal depth. As steep slope is there, it means that there is a supercritical flow condition, that is the maximum amount of velocity is associated or flow is governed by the velocity, we can say rather, and minimum depth and maximum velocity. Then the next type of the channel slope was the horizontal channel slope, in which the bed slope was the zero, that is a purely horizontal, and we had seen that the normal product is at infinite and it can't sustain the uniform flow. Also for the adverse channel slope, where the channel slope is in the reverse direction, that is normal product is imaginary and it can't sustain the uniform flow condition. Those are the classification of the channels. So we had seen those in detail in the previous class. This is the schematic sketches of all the channels. This is the mild one, this is the critical one. In mild we had seen all three zones or all three regions of the flow exist. It is above, that is NDL and CDL are the separate one. Whereas in a steep slope, again three regions used to exist. For the critical, there exist only two zones, that is zone 1 and zone 3, where NDL and CDL are one and same, they intermingle with each other. And for horizontal and adverse, again there exist two zones, there is region 2 and region 3 for both of them, and for them they can't sustain the uniform flow conditions. That part we had seen. After that, we have discussed about the water surface profile, so we'll have a quick review of that and we'll proceed further. In the critical channel slope, there are two zones, two profiles, that is a C1 and a C3, that is in a region 1 and a region 3. Conditions of formations for them: for C1, critical flow depth and normal flow depth are less than the actual flow depth, whereas for the C3, the actual flow depth is less than critical and normal flow depth. Then for the mild channel slope, three regions exist, means three profiles exist: M1, M2, M3. Conditions for them: for M1, the flow depth, that is actual flow depth Y, is above the NDL and CDL. For M2, flow depth is below the NDL but above the CDL, and for M3, actual flow depth is below the CDL and NDL. Okay, and the regarding the slope of the energy line, that is a dy by dx, sorry, slope of the water surface, rather we can say dy by dx, that is a positive for zone 1, region 1, negative for zone 2, and positive for zone 3. It is applicable for all the channel slopes. After that, we had seen the steep slope where two regions used to exist, three regions used to exist, and three consecutive or corresponding surface profiles also exist. Conditions were for region 1, that is S1, flow depth, actual flow depth is greater than critical and is greater than normal also. dy by dx, that is the slope is positive. Region 2, critical flow depth is greater than actual flow depth and is also greater than the normal flow depth, where this is the region 2. CDL is at the topmost line we can say, and the NDL is the lowermost line we can say. As far as classification is concerned, no doubt that the fundamental base is nothing but the channel bottom itself. But in region 2, the flow is to occur here somewhere, where we are finding that the actual flow depth is less than CDL, or the flow profile or the water surface is below the CDL, that is critical depth level, but it is above the normal depth level. It means that the Y is actual flow depth Y is below the CDL but above the NDL, that is Y is less than YC but greater than YN. And for the third region, here we are finding that actual flow depth is below the NDL and below the CDL, that is less than YN and YC. That part we had discussed last time. The next one, that is a horizontal, where only two regions used to exist, the YN, that is second and third, and normal flow depth exists or occurs at the infinite dimension. So corresponding two water surface profiles used to exist for that, and those are H2 and H3. And conditions of the formation for H2 and H3 are H2 here, that is the Yn is greater than Y but less than Yc, and for region 3, actual flow depth Y is less than critical and normal, that is Yn is greater than Yc is greater than Y. Okay, so that part we have discussed. Now we will move further for the next part, that is control sections. So in the previous lecture, I had some of the trick about the control section, what they are and what they indicates about. So control sections are nothing but the points which indicates the definite relationship between the flow depth and the discharge. Generally, those points or those sections are considered as a control sections in the channels. So what does it they mean, or what they used to about? So they means about below that, below them or above them, means before the control sections and after the control sections, our GVF equations are not valid, we can say. Or the profile is to either start from them, or the profiles is to exist up to them. That is the meaning for the control section. I will see that one by one. So control section is defined as a section in which a fixed relationship exists between the discharge and the depth of the flow. It means that for control sections or the channels or the length of the water surface profile existing between the two control points or the two control sections, we can say, in that region the definite relationship is to exist between the discharge and the associated flow depth. And for each and every water surface profile, there is to have at least one control point. So control point is that at which for a given discharge the depth of the flow is known or it can be controlled to a required value. That means at that point, at that control point, we are able to control, or we need to have the definite magnitude for the flow depth. Or if we are knowing the flow depth, then we can correlate the discharge for that particular sections. Then the critical depth is also a control point. So for any channel section or for a regular channel sections, we can say if we are not able to find the control section or the control point, in that case there is to exist, or there we can say that the critical depth or the critical line CDL is nothing but the control point. Means above that CDL and below the CDL, we can say that the control point is to exist. So whenever there is a control points are not mentioned, then in that case we can treat the critical depth line or CDL line as a control line or control point over that, or region in between that as the control the region, we can say. The next part is the for any GVF, it is for any gradually varied flow profiles, there used to have at least one control section or at least one control point, we can say. Surely it has to be, because we had seen in the previous session that for any GVF profile near to the control lines or near to the CDLs and the NDLs, there we had shown them by the dotted lines. Means those dotted line indicates that at those regions the GVF equations are not valid. It means that from those dotted lines or in between the dotted lines, whatever the continuous line we had shown for the flow profile, that is nothing but the our control section, and from those points the control section is to start. Okay, so then if, for the depth relationships, we can say in general sense we can say if the depth of non-uniform flow, means for a GVF, if the flow depth is y is above the critical depth, means actual flow depth y is above the critical depth, then the control section is governed by the downstream control. What does it mean about, ज्या वेळेस आपली ऍक्च्युअल फ्लो डेप्थ y जी असणार आहे तिचं मॅग्निट्यूड हे जर का क्रिटिकल डेप्थ पेक्षा म्हणजे क्रिटिकल फ्लो डेप्थ पेक्षा जर का जास्त असेल तर 100% त्या प्रोफाइलवरचा कंट्रोल पॉइंट हा गव्हर्निंग कंट्रोल पॉइंट हा डाउनस्ट्रीम एंडला असतो. How is it so? We will see with the example. Now for the M1 water surface profile, as we are knowing that for M1 water surface profile, it is in a region 1. It means that it's a flow depth in the region 1, that is actual flow depth y, we can say is more than normal depth level and more than critical depth level. Here we are concentrating about the critical depth level. So the y is above the critical depth level. So in that case this control section is governed by the downstream control. It means that we'll have the control for such conditions where actual flow depth y is above the normal flow depth. There the control point is to exist at the downstream end. म्हणजे जिथं आपलं फ्लो प्रोफाइल चेंज होणार पुन्हा एकदा, म्हणजे इथून पुढे ड्रॉपडाऊन होत जाणार, इथं पाठीमागे आपलं बॅक वॉटर आहे, तर इथं हा पॉइंट काय इंडिकेट करतो, तर हा आपला कंट्रोल पॉइंट इंडिकेट करतो. म्हणजे याच्या पाठीमागं म्हणजे बॅक साइडला आपलं फ्लोचं जे प्रोफाइल असणार आहे, in the upstream side we can say from this point the water surface profile is a back water surface profile, whereas to the downstream end of this control point there is a drop down water surface profile. So this is nothing but the control point which disintegrate or clearly indicates the, just a minute, I would like to mute all the participants. So this indicates the change in the water surface profile. It means that this is nothing but the control point. Whereas if we look towards the upstream end, here herein there is a M1 here shown. Here we are finding that so for a so long length the water surface is going to intermingle with respect to the or with the normal depth level. म्हणजे खूप लांब अंतरावरती पाठीमागच्या साईडला नॉर्मल डेप्थ लेवल बरोबर वॉटर सरफेसची जी आपली हाईट असणार आहे किंवा जी फ्लोची डेप्थ असणार आहे ती खूप लांब अंतरावरती जाऊन मिक्स होणार आहे. म्हणजे पाठीमागे खूप अंतरावरती कुठेतरी जाऊन कंट्रोल पॉइंट असणार आहे. म्हणजे याचा अर्थ काय, तो कुठेतरी जास्त अंतरावरती असेल तर तो आपण सहजासहजी त्याला मार्क करू शकणार नाहीये. अशा केसमध्ये जो आपला कंट्रोल पॉइंट गव्हर्निंग जो असणार तो कंट्रोल पॉइंट हा कंपल्सरी डाउनस्ट्रीम एंडला पकडला जातो. म्हणजे या प्रोफाइलसाठी हे डाउनस्ट्रीम एंड झालं. परंतु का बॅरियर कन्स्ट्रक्ट केलेला आपण कन्सिडर केलं, यू आर कन्सिडरिंग द डॅम एज अ बॅरियर, देन फॉर द डॅम दिस इज अपस्ट्रीम एंड. Okay, for dam this is upstream end, but for this profile this is a downstream end, because for profile is originating from this point somewhere else. So this is a upstream end for the profile. So in respect to the profile, we can say where the flow depth is greater than a CDL critical depth level, then the control point is governed by the downstream control, or the control point is to exist at the downstream end. This is about the first condition where y is greater than yc, then the profile or the it is governed by the downstream control point. Then the next one is if the depth of non-uniform flow, that is a depth of the GVF, is less than critical depth, means now the flow depth is below the critical, it means that the flow is a supercritical, the velocity is high, depth is less, thought number is more. In that case it is governed by the upstream control. म्हणजे इथं बरोबर पाठीमागच्या केस पेक्षा रिव्हर्स केस असणार आहे. ज्या वेळेस फ्लोची डेप्थ ही ऍक्च्युअल फ्लो डेप्थ ही क्रिटिकल फ्लो डेप्थ पेक्षा कमी असेल त्यावेळेस ती फेनॉमिनन किंवा ते कंडिशन ही अपस्ट्रीम कंट्रोलने गव्हर्न केली जाते. तर का सुपर क्रिटिकल फ्लो कंडिशन असेल तर म्हणजे याचा अर्थ काय झाला की आपण बरोबर थर्ड रिजन मध्ये आहे, मीन्स जस्ट अबाउट द चॅनल बेड. वी विल सी विथ एक्झाम्पल. So see over here, this is a third region, this is a second region, and this is a first region. Again, the same channel slope we have considered here, that is a mild channel slope. So this is a CDL, critical depth level. This is a NDL, that is normal depth level. YN, that is a Y0 here I had shown. So Y0 or the YN indicates the normal depth level, and this depth is nothing but the critical one. So now consider for the our given condition, that is a flow depth Y is a less than CDL. It means that the flow depth that is a critical at flow depth is below the CDL, means we are in a region 3 here. So in the region 3 we are finding that below the sluice gate, this is an sluice gate, and the water is ponded on the upstream side of the sluice gate and it has been released through it, means we have lifted that sluice gate, due to which there is a gap between the channel bed and the bottom surface or the bottom point of the sluice gate, and through which the water is now releasing or water is getting moving towards the downstream end. And while doing so, the whatever the water surface we are observing here, that water surface height or the actual flow depth height we can say is below the CDL. And for this condition, number of the times we used to observe that while water coming or the liquid coming from this point or escaping from this point, we used to observe the variation in the flow depth. It means that here we can't get the actual flow depth easily, but after certain point or after certain length in the x direction, we used to get the constant or a somewhat constant the flow profile or the flow surface rather we can say. So in this case we can say the control point used to start from this region, from where we are able to have or we are getting the exact relationship between the flow depth y and the discharge q which is passing through it. It means that for this condition or such conditions the control point is at the upstream. Why upstream? Now no doubt that for this sluice gate this is a downstream end, but for this profile it is a starting point, so this is an upstream end or starting point for the profile. Whereas in this case, that is for M1, that is the previous case we had seen, this is nothing but the downstream end, because its upstream end is somewhere else here, and this is the downstream end for the region 1. But in the region 3 where the critical depth or the flow depth is to be less than the critical depth, in that case such conditions are governed by the upstream control. So this is the upstream control, this is the upstream point of the water surface profile M3. So this is about the control point and the control sections. Now where up to which point we can consider the control section? So up to the point or the up to the length rather we can say in the longitudinal direction or along the bed, up to which we are able to establish the formal relationship between the flow depth y and the discharge, that length we can consider as a control length or the control section. So up to for this case we are finding that up to this case we are able to or we are observing that there is a constant water surface. Time being we are observing here there is a constant water surface. It means that up to this point we can say that there exists a control section or the control stretch. But after here we are finding that there is a existence of the hydraulic jump. Okay, that hydraulic jump we are going to discuss in the next part. So this is about the conditions regarding the control point and control sections. Now we'll move further. There is Afflux, which was remained from my side to discuss about. So what does it mean about the Afflux? Afflux and surges. We used to hear a number of the times that is the Afflux has been passed and all the surge has been passed. So what does it mean they about? We'll see that with respect to the example itself. So that once again this is a channel bed and it has been constructed a dam, that is a barrier in the channel itself, due to which the water surface has been raised. So we'll consider that this is an initial water surface or initial water depth, that is y1, and due to the construction of the barrier in the form of the dam, the water surface has been elevated, that is depth has been increased. So at this dam section we are finding that the water surface has been elevated up to this point, or the depth has been increased up to this point. And when we are moving in the reverse direction, that is in a backward direction from the dam itself or towards the upstream side of the dam, that is towards the y1, we are finding that there is a decrease in the flow depth, and at some point we are finding that there is a intermingling of the actual water surface and the height of the water surface, which has been raised due to the construction of the dam. So if we will measure that height of the water surface, that is the maximum height over the dam surface, there is nothing but the y2 here we can say. Then the elevation difference between those two heights, that is a y2 and the y1, means we can say the actual this one we can say this is nothing but the afflux. So the afflux is nothing but the distance between or the vertical height between the or the vertical elevation difference between the water surfaces of actual and the elevated one. So that's nothing but the afflux. आपण हे बऱ्याच वेळा बघतो की नदीमध्ये सुद्धा आपण बऱ्याच वेळा ऑब्झर्व करतो, जर का खूप मोठा वारा जर का सुटला तर आपल्याला एक वेव अशी पुढे अशी पास झालेली दिसते. That is also we can consider as an afflux, but that is considered as a surge there. Rather, there that is considered as a surge. Surges are also put two types: positive surge and a negative surge. Okay, but afflux, specifically talking about, it is the elevation difference from the between the actual flow depth and the flow depth which has been there, or the water depth which has been raised due to the construction of the dam. So this is about the afflux point we can say. Then we'll have a quiz. The statement for that: the water surface slope dy by dx in case of a uniform flow in the channel is equal to, for the uniform channel section, the slope of the water surface, that is a dy by dx, is equals to, options are a as a 0, b as a 1, c as a 1000, and d as a infinity. Now I have discussed that part, so with respect to that you can give the answers. This is the condition for uniform flow, and for uniform flow condition, what is the ratio dy by dx? Those are knowing they can go for, otherwise I would like to go for the answer. Okay, one of the answer I got as an a, that is a 0 slope. Again I got the a. Fastly again the a answer. Those are knowing the answers, they can go for. Those are not knowing, they can also try for. Fastly. Okay, again I got the a answer. Oh, so okay, we got the answer A. Again, okay, I got the B. Two respondents have given as answer B. Okay, we'll go for the answer. The condition is that water surface slope dy by dx in case of uniform flow. Okay, now you can check your answer. The correct answer is the answer A. Okay, so for this condition, the correct answer is the answer A. How is it so? Because for uniform flow condition, we had seen that the channel bottom slope and the water surface are parallel to each other. It means that the y is a parallel, or the flow depth which is there at the depth y is exactly a parallel to the channel bed. म्हणजेच हॉरिझॉन्टल लाईनला किंवा चॅनेल बॉटमला वॉटर सरफेस हा पॅरलल आहे. म्हणजे जसं जसं आपण मूव्ह करू कुठून एका पॉइंट पासून दुसऱ्या पॉइंटला, जर का आपण एक्स डिस्टन्स कव्हर केलं तर वाय मध्ये काही व्हेरिएशन होणार नाही. म्हणजे याचा अर्थ काय, डीवाय बाय डीएक्स इन द सेन्स काय असणार थोडक्यात की y2 मायनस y1 बाय x2 मायनस x1. y2 y1 ह्या सेम असणार, x2 x1 काहीतरी डिस्टन्स मिळेल आपल्याला, पण न्यूमरेटर 0 असल्यामुळे तिथं कंपल्सरी येणारा रेशो आपला हा 0 असणार आहे. Okay, we'll go for next one now. The statement is a mild slope channel enters a lake with a sudden drop. A mild slope channel enters a lake with a sudden drop. म्हणजे कंडिशन काय आहे, माइल्ड चॅनल स्लोप आहे आणि तो कुठे एंटर करतोय तर लेक तळ्यामध्ये एंटर करतोय. ओके, म्हणजे काही केलंय, एक चॅनलच्या आउटलेटला एक लेक फॉर्म केलेला आहे आणि त्या लेक मध्ये माइल्ड स्लोप चॅनल एंटर करतोय. इन चॅनल drops in its bed. Okay, if the depth of water in the lake measured above the channel bed, म्हणजे तळ्यामधली पाण्याची जी डेप्थ आहे ती चॅनलच्या बेडच्या वरती मोजलेली आहे, that is the YL, means the depth of the water above the channel bed in the lake is the YL is greater than the critical depth. That YL is greater than critical means YC. Then the depth of the flow in the canal at the outlet, then depth of the flow in the canal at the outlet, that is y suffix d we can say. म्हणजेच कॅनलच्या आउटलेटला कॅनल मधली जी फ्लोची डेप्थ असणार आहे y suffix d, what would be the relation with respect to the L? I will go for once again. Mild slope channel enters a lake with a sudden drop in its bed. If the depth of water in the lake measured above the channel bed at its outlet is YL is greater than the critical depth, then the depth of the flow in the canal at the outlet, that is YD, is ratio YD is equals to YL. ऑप्शन ए काय सांगताय तर कॅनल मधली जी डेप्थ मेजर केलेली आपण कुठं कॅनलच्या बेडच्या लेकच्या ठिकाणी, लेक मध्ये ती YL बरोबर YD एवढी आहे. सेकंड ऑप्शन YD is equals to YC. Third option is equals to normal depth y0, and the last option is less than y0, that is y0 means normal flow depth. So here the answers. कंडिशन काय आहे, माइल्ड स्लोप चॅनल आहे तो एका लेक मध्ये एंटर होतोय, जर का तसा तो एंटर झाला तर त्या केस मध्ये जी कंडिशन असणार आहे, कोणती कंडिशन तर जी फ्लोची डेप्थ जी मेजर केलेली आहे कॅनलच्या बेडच्या वरती ती जर का YL असेल आणि ती जर का क्रिटिकल डेप्थ पेक्षा जास्त असेल तर ऍक्च्युअल कॅनलची जी डेप्थ असणार आहे आउटलेटला ती काय असणार आहे. ओके, आन्सर सी आय गॉट, देन आन्सर ए आय गॉट, 2 3 4 answers I got. Again, hit the answers fastly. Okay, D I got from someone else. Again I got the D, that is less than normal flow depth. Can we go for the answer? Okay, so we'll go for the answer now. It is a answer A, that is equals to the flow depth which has been measured at the outlet of the lake but above the channel bed. How is it so? I would like to go for description of the same, explanation of the same. Now here the YL is the flow depth which is measured in the lake, but where it is measured? It is measured above the channel bed at its outlet. म्हणजे कॅनलच्या आउटलेटलाच ती डेप्थ मोजलेली आहे, परंतु कुठे मोजलेली आहे, लेकच्या ठिकाणी, परंतु चॅनेलच्या आउटलेटला मोजलेली आहे. आणि ती किती मिळालेली आहे आपल्याला तर YL एवढी मिळालेली आहे, परंतु त्याचं मॅग्निट्यूड हे ग्रेटर दॅन क्रिटिकल आहे. आता आपण विचारलेले काय तर फ्लोची डेप्थ दॅट इज अ डेप्थ ऑफ फ्लो इन द कॅनल ऍट इट्स आउटलेट ऍट द आउटलेट म्हणजे वन अँड सेमच झालं. हे सुद्धा कुठं होतं चॅनल बेड ऍट इट्स आउटलेट वायल होतं. हे सुद्धा कुठे आहे कॅनल ऍट इट्स आउटलेट. इट मीन्स दॅट बोथ आर वन अँड सेम. क्लिअर अबाउट? विल प्रोसीड फॉर द नेक्स्ट. Identify the incorrect statement. Identify the incorrect statement. The possible GVF profiles in mild slope channels are M1, M2, and M3. Second, if someone has marked that notations, please do remove it because it is exactly matching over the option A. Okay, so options are mild slope channels are M1, M2, M3. In adverse slope channels are A2 and A3. In horizontal channels they are H1 and H3, and in critical slope channels they are C1 and C3. We have to identify incorrect statement. Okay, we have to identify incorrect statement from these four statements. First statement, in mild slope GVF profiles are M1, M2, M3. In adverse slope they are A2, A3. In horizontal they are H1, H3, and in critical they are C1 and C3. What is the correct answer? Which is the not match? Okay, D I got. Again, okay, A, okay, again D, okay, B, again B, C. We have to identify incorrect statement here. म्हणजे इथं आपल्याला 4 स्लोप दिलेले आहेत आणि 4 स्लोप मधले फ्लो प्रोफाइल्स दिलेले आहेत. मग याच्यापैकी कोणतं रॉंग स्टेटमेंट आलेलं आहे ते विचारलेलं आहे. अगेन आय गॉट द बी आन्सर. कॅन वी गो फॉर आन्सर? Okay, again got the C. Just remove your notation, so we'll go for the answer. Be fast and just mark the points so that we'll get the idea. So the correct answer is answer C. That is, in horizontal channels H1 and H3 we have marked. The statement is in horizontal channels the flow profiles are H1 and H3, but for horizontal channel the region 1 doesn't exist because the yn, that is normal product, it is at infinite distance. We can't predict that. It means that region 1 is imaginary and there exists only the region 2 and region 3. Okay, so as like an adverse channel slope, in a horizontal channel slope also exists only two regions, that is a region 2 and region 3. It means that this statement, that is a horizontal channels are H1 and H3, is a incorrect statement. Okay, got it? Now we'll go for the next one, next quiz. Just remove those notations, sir. Fastly. The following type of GVF profiles do not exist. The statement is the following types of GVF profiles do not exist. Option A, C2H2A1. Option B, A2H1C2. Option C, H1A1C2. And option D, C1A1H1. Statement is that following types of GVF profiles do not exist. याच्यापैकी कोणते GVF profiles exist होत नाहीये. ज्या पेअर दिलेल्या आहेत तिघांच्या, तर तिघांपैकी कोणतं exist होत नाहीये. ओके, C. Again, just one answer I got. Again C. Just mark the points or just stretch the arrows over, okay, so that we'll get the idea. Fastly. Answer D. Okay, answer B. Again, anyone else? C. Okay, B someone has marked. Intentionally I am not taking the names of the participants. Okay, can we go for answer now? We'll go for the answer. Just remove the notations. Just clear the notations. So the correct answer is a C. का बरं C असणार आहे? कारण A1 H1 दिलेला आहे. A1 H1 आपल्याला माहिती आहे, हॉरिझॉन्टल आणि ऍडव्हर्स स्लोपला रिजन 1 एक्झिस्टच होत नाहीये, बरोबर. आणि C2 म्हणजे क्रिटिकल स्लोपला YN आणि YC ह्या दोघं इंटरमिंगल झालेले असतात. म्हणजे हे